Okay, so this is this part 2 to cover 4.2. So we're taking fractions and we're going to express that in simplest form. So let me start off with 2 over 10. So we're going to break it out using factors. So the factors for 2, the only way you could break that out is 2 times 1. So we know that's a prime number. So I'm not going to express it that way. I'll just write it as 2 because I can't break that down any further. But when we look at 10, thinking of our multiplication, we know that 2 times 5 equals 10. So we're not changing the value, we're changing the appearance. And we also learned that 2 over 2 is equal to 1. Even if it's 100 over 100 in your numerator and your denominator, that's equivalent to the whole number 1. So the same thing applies here. Whenever we have this 2 over 2, we know that will reduce down to 1. So we'll rewrite that as 1 over, and then it's 1 times 5. And then I'm just going to write that as 1, and we know 1 times 5 is just 5. So you could write it like that, or you could easily just write 1 over 5 as your final answer here. So that's a simpler number. Now, if we're going to go to something like 20 over 70, now most students, if they use a 2 or a 3 to start breaking it down, it may be a lot of steps. If you have your multiplication table memorized or in front of you, you might quickly see that you can use a higher number than 2 or 3 to break it out. Like if you have 10, you can get a 10 on the top and the bottom because 10 times 2 is 20 and 10 times 7 is 70. So you can see the 10s reduce out to a 1, divides out to a 1, and you can see your final answer now is just 2 over 7. Now, if we used a different method, we used 2, 2 would have been a lot longer process, where again it would have been 2 times 10 here, and then we would have 2 times, and let me bring the calculator up so you can see. So you would take, we have the other number, which is 70. We can see that. So we would take 70 divided by 2 equals 35. So we know now that 2 times 35 equals 70. So you can see the 2's will divide out to 1, but however, the 10 and the 35 is not prime numbers. We can break that down even further. So you would have 2 times 5 is 10, right? And we know 7 times 5 is 35. So now the 5's will divide out, and then you could see now the same answer. It's just using a, you can see this method, we had to provide more steps to get the same answer as the one above. But if we know our multiplication, if we can get a higher number than using 2 or 3, you can see you can get to this step much quicker. So that's the approach I'm going to try and take as I'm showing you these examples. All right, so let's try another one. So if I have something like 15, let me write this a little bit lower. So if I have 15x squared, okay, and that's all over 25x, all right. So the first thing I'm going to think is, well, I'm going to think of my 5 times something that gives me 15 and 25. And if you recall, 5 times 3 will give us 15. But look, I have an x to the second power. So remember, that's the same thing as x times x. That's equivalent to x squared. So let's just break those up in those factors, x times x, just like that. And that's multiplication. So that's really truly the same value. It's still 15x squared. And let's do the same thing below. We know 5 times 5 is 25 times, and there's only one x down below because this is really x to the first power. Now we start dividing out, so these two will divide out to 1, and look, and the x's will even divide out to 1. So now I'm just going to go ahead and gather what I have on top, and on the top I have a 3 and an x, so we can write it as 3x. That's the same thing in this notation. It's still saying 3 times x. And on the bottom, all we have is a 5 remaining. So this is your final answer. It's in simplest form. We took this fraction here, and we reduced it down to simplest form using factorization. All right, let's go ahead and try another one. So if I have a number like 32x cubed y squared. Now we have an x and a y, and that's all over 48. And then we have x, y. So if you think about 8 times something, if you have that memorized, you can use your calculator. So you can use 32 divided by 8. You can see that 8 times 4 is 32. And if you have 48 divided by 8, you can see 8 times 6 is 48. So I'm going to write those multiples out. So 32 would be 8 times 4. That's 32. And the x, I'm going to write it out 3 times, because that's x cubed. And then y squared, you're going to write it out 2 times. All over, and then remember, 8 times 6 times, and an x is on the bottom, and the y, there's only to the first power, so you can only write those out 1 time. Now, if we start dividing out, this will divide out to 1, this will divide out to 1, and then we can get this and this one, those will divide out to 1s. Okay, so I'm going to go ahead and collect and gather what I have left on the top. So I have on the top, I have a 4. So let's see, I got a 4, an x, and a y. So how do I write that? Well, I write it as 4x squared y all over. And on the bottom, the only thing I have is this 6. So I'm going to write the 6. Now, I have to ask myself, is that in simplest form? It is not, because it's in simplest form when it's a prime number, and 4 can be broken down as 2 times 2, and 6 can be broken down as 2 times 3, so it can be broken down even further. So I'm going to go ahead and do that. So I'm going to write this as 2 times 2 times x squared. We don't have to worry about these variables anymore. They're all taken care of. And on the bottom, we have 2 times 3 to express that 6. Now we can see the 2's will divide out to 1. And our final answer at this point would be, on top we have 2x squared y. And on the bottom we have 3. And that would be your final answer for this problem here. That's now in simplest form. All right, so let's try another example. Let's see. All right, so this one's a little bit of a high number. So if I have 184 xy, and it's all over 64 xyz. Now, the first thing I'll say to myself, well, I can recognize that number. I know that 8 times 8 equals 64. So let's see if 184, let's see if that works for 184 too. So I'll go 184 divided by 8 equals, and it does. So 23 times 8 is 184. So I'm going to go up here and I'm going to write it out. So I know 8 times, so I have 8, let me erase that. 8 times 23 we know is 184 times the x times the y. And then on the bottom we know 8 times 8 will give me 64 times x times y times z. Now let's see what divides out to 1. Well, these are the same number on the top and bottom, so that'll divide out to 1. We have an x on the bottom and the top, that'll divide out to 1. We have a y on the top and the bottom, that'll divide out to 1. So now let's go ahead and gather what we have left over. So on the top we have a 23, and then on the bottom we have, it looks like we have an 8 and a z. So I'm going to write those, so that would be 8z. So there you go. Here is this fraction in simplest terms using the factorization. All right, so now let's go to another problem. It's going to ask you if it's equivalent. So here's the next terminology in your set of instructions. Are they equivalent? So they'll give you two fractions. So they'll ask you, is 7/10 and 3/4 equivalent? Well, if you look at those, you can't see. Just by looking at the fractions, the numbers, it doesn't look like this. If you had something like this, is that equal to this? Well, you say, sure, it's exactly the same fraction. Now, there's this method you can use. It's called cross multiplication. So you're asking, is 7/10 equal to 3/4? That's the question. So they say, well, if you use this cross multiplication method, you can determine that. So what they're saying is you go take the first one, which is 10 times 3. Is that equal to 7 times 4? And if you were to plug those into the calculator, you would see the first one is 30, And this answer here is 28. So that is, whoops, I'm sorry. Get back to that screen. Where's it at? Okay, so that is not equal to. So this answer would be no, it is not equivalent. All right, so let's try another example like that. So, and this would be number 10 in your homework. So if they give you another fraction such as, let me change this color, if they have 3/12 and 2/8, and they're asking, are they equivalent? Well, you can use the same method again. You can just take 3/12 and you're trying to determine, is that equal to 2/8? And you can use your cross multiplication method. So what you're saying is I'll take 12 times 2, is that equal to 3 times 8? And we know 12 times 2 is 24, and we know 3 times 8 is 24. So 24 is equal to 24, so that one would be yes, it is equivalent. These two fractions here are equivalent because we use this cross multiplication method to determine so. All right, so now let's go to number 8. So number 8 is asking us just to take this fraction. I'm sorry, number 11 is asking us to take this fraction, and they're asking for the simplest answer. So we're going to simplify it. So I'm going to look at 8, and I know I can't get an 8 out of the 10, but I know these can both use the same factor of 2. So 2 times 4 is 8. And 2 times 5 is 10. So we can see the 2's divide out to 1, and our final answer here is 4/5. All right, so how about if another one, the next one, which is number 12 in our homework, if it gives us something like a fraction like this, and it wants it in simplest form, so using the factorization, so I can see I can get a 10 out of both of those, because 10 times 2 is 20, and 10 times 5 is 50, and we could see that will divide out to 1, and our final answer is 2/5. See how multiplication table can really help you? All right, now, oh, I'm sorry. This one's a word problem. So this one's number 12. So let's go over to that one. So if I go to number 12. All right, so number 12 is saying 20 states in the country have 4 hotels, 4-star hotels. So assume that the country has 50 states. So the first thing it's saying to you when you're looking at this, it's saying 20 out of 50 are 4-star hotels. So if we were to take that in simplest form, that's how we end up with the 2 times 10. Well, let me start with the 10. We have the 10 times 2 over 10 times 5. This reduces down, and that's how you end up with 2/5. Because when you look back to your problem, it's saying the fraction of, this is A, the fraction of the states with the 4-star hotel is, which I showed you, it is that, and it reduces down to 2/5. So when you go back to this, it shows you simplify your answer. Now it's asking for the number of states without. So if it's without, you're saying that, okay, well, let's take the 50 minus the 20, which gives us 30. And these are the ones without. So that's why the answer here is 30. Now it's saying express that as a fraction in simplest form. So how we would do that is take the 30 over the 50, and the same thing, 10 times 3 over 10 times 5, and it reduces down to 3/5. And that's the other part of that question. So it's the one that's without and expressing it as a fraction in simplest form. And finally, lastly, the last one would be if there's 192 containers of juice and 69 of them are orange juice, what they're saying to you, how you express that as a fraction, remember it's the whole is in the denominator. So it'd be 69 over 192. But you can break that, you can get a 3 out of that. And this, you got to put that in a calculator and try a 2 or 3. And if you divide 69 by 3, you'll see that 3 times 23 is 69. And you also see 3 times 64 is 192. So that's 23 over 64. And that's my 15 minutes.